So here we go. Sounds good. All right. The mysterious chapter X. Your grade 8 teacher will be happy. We are going to use, first of all, I guess we should get a definition out of the way. A line segment is a portion of a line with two endpoints. We math teachers like to be very precise about the way we define things. So this little segment here, what do you need? You don't even have paper? I don't know that I have any loose leaf. I have like scrap paper you can use. You can help yourself to that. Yeah, man. Get it together. This is high school. You got to have your stuff. All right, anyway. Hold on a minute. Join this from here to A to B. I'm going to try to draw this nice and pretty. There we go. Oh, it kind of moved on me. Oh, well. Close enough. That's not a line to a mathematician. That's a line segment. A line technically goes forever in two directions. Anybody know what you call it if it goes forever only in one direction? Begins with an R. 3 letters.
Mr. Kello, you're not sharing your screen.
Oh, I'm not?
No.
Oh, I'm sorry. I thought it was. Okay, my bad. R. Anybody have? I don't think anybody got it. R, 3 letters. It's array. Correct. If you go forever in one direction. Here, let me draw them. Sorry about that. Guys at home, can you see it now?
Yep.
Okay, my bad. Okay, so if you have it in one direction, it's array. You don't have to write this down if you don't want to. If you have forever in two directions, it's a line. And of course, we're concerned now about line segments. So, you know, we're very specific about definitions in math, especially the geometry types, right? You ask a geometer what the center of a triangle is, and he'll say, do you mean orthocenter? Do you mean circumcenter? Do you mean, what are the other two? The centroid, and then there's one more. Actually, there's more than that, but there's 4 main ones. So yeah, you got to be specific in what you say.
How can you have 4 centers of a triangle?
Because it depends on how you want to define center. Right? We could have that conversation sometime if you like, but not right now. I want to get through this. Okay, so the other thing, so we have this definition. The other thing, again, this will make your grade 8 teacher proud. We do have to recall good old Pythagoras, that if you have a right triangle, and let's say it has a height of A, a base of B, and a hypotenuse of C, what is the relationship between those 3 sides? A squared plus B squared equals C squared, right? Good old Pythagorean theorem. All right. So that's where we're starting, with those 2 ideas in mind. And hang on a sec. Chapter X. There we go. All right. So if I want to find the line segment length from A to B, what we can do is we use the Pythagorean theorem. Some people call it the Pythagorean identity. And we can say that we'll call the distance from A to B, we'll call it D. And of course, think about how we'd calculate slope. We'd get the rise and the run. So we're already fairly used to looking at those sides. This is 2 and this is 4. So D then, D squared, because that's the hypotenuse, D squared, is equal to 2 squared plus 4 squared. And of course, D squared is equal to 4 plus 16. So D squared is equal to 20. And then of course, the bane of all grade 8 teachers is the students are like, there, I'm done. The distance from there to there is is 20. Look at it. The distance there from there to there can't be 20. Right. I don't want to know what D squared is. I want to know what D is. So I square root it, and I get square root of 20. Of course, again, a mathematician would look at that and not say that that's the most simplified answer. We'll talk about this next unit. We'd call this, of course, 2 root 5, if you like. Or we could go to a
Or we
decimal.
could actually say what the thing is.
Well, this is what it is. Remember, all decimals are approximations. That's an exact answer, right? So now from here, note, let's write a little note. Note. The distances 2 and 4, I mean, yes, they're rise and run. That's the way we've been thinking about them for the last couple units, as rise and run. But you know what else they are? They're the result, I should say are the result of subtracting the x and y, oops, I meant to say and y, and I said any, oops, and y coordinates of point A and point B. So let's look at the coordinates here. What is the x comma y of point A? What's its address? Where does A live? Well, it lives 2 to the right and 1 up. X is 2, y is 1. What's the address on B? 6 to the right and 3 up. So do you see where that 4 comes from? The 4 is 6 minus 2. See where this 2 comes from? 3 minus 1. I feel a formula coming on. The distance formula is, now, remember, d squared is what I got here, but what did I end up doing once I hit that last step? I ended up square rooting the other side. So this formula is going to have a great big square root for the other side. And in here, I'm going to have x2 minus x1 squared plus y2 minus y1 squared. Make sure the square root goes over the whole thing like that. And that's the distance formula. And yes, we'll give it to you, but we won't tell you what it is. We'll just give you here. This is on the formula page. It won't say, hey, this is the distance formula. You've got to remember that. And this formula represents distance between 2 points with coordinates. I just misspelled coordinates. Let me fix that. Coordinates. x1, y1, and x2, y2. And again, those 1s and 2s just are saying first x point, second x point. So take a look. Let me just shrink this a bit so you can see both my notes and the example at the same time. There we go. Take a look at what we did here, right? We got that this line was 4. How did we get it? Well, we counted spaces on the page. But we could have got it by going this 6 minus this 2. So 6 minus 2, all squared. Right here, 6 minus 2, all squared. How did we get this 2? 3 minus 1, all squared. Now, somebody might go, but wait a minute. I was going to call this one x2. Because rather than reading from left to right, I was going to read from top to bottom. Would it matter? And the answer is no. Because notice if I'd have gone to find this distance here of 4, if I'd have gone 2 minus 6, I'd have got a distance of negative 4. And on this picture, calling that distance negative 4 is a bit silly, right? How can that be a negative space? But you know what? In geometry, lines can go in negative directions. Those of you who've done some science, you know that you can just assign a direction to something and then call it negative. But what would have happened to a negative 4 in here anyway? What happens when you square any negative? What's a number times itself have to be? It has to be positive, right? So it actually doesn't really matter which point you call 1 and which point you call 2. As long as you stick to the same kind of scheme. If you say, okay, this is my point where I'll call this x1, then the coordinate here has to be y1. And then same thing here, x2 and y2. All right, let's use our formula. Well, okay, here's the thing. Can I just cancel those square roots because, you know, I'm squaring a square root? Let's see. let's say that I was doing this triangle here. Let's pick something. You don't have to write this down. This is a good question. Let's explore this a little. This was probably the first Pythagorean triangle you ever got introduced to. Good old 3, 4, 5, right? Because 3 squared plus 4 squared equals 5 squared. For those of you who don't remember that, 9 plus 16 is equal to 25. Okay, let's pretend we didn't know that this was 5. Let's call it D. And let's say we went D squared is equal to 3 squared plus 4 squared. But again, I might say, oh, I don't feel like squaring those numbers. Why don't, since I know I have to square root both sides, since D is going to end up being this, why don't I just cancel those squares with the square root?
3 plus 4 is not 5.
3 plus 4 isn't 5. So that didn't work. Now, why didn't it work? I mean, in my world, if I multiply by something, then I divide by that something right away, they should cancel. I should be back at the same something. If I add 2 to a number, then I take away 2 right away. I should be back to my original number. Why can't I square something, then square root it right away, and get the same number? It works with single numbers, right? If I take the square root of 4 squared, isn't that just 4? Yeah, square root of 16, yeah. So why didn't it work here? And the reason it didn't work here, dum, 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 is because of the add. Actually, this is a bedmass violation. Whatever. Technically speaking, you actually learned this in grade 9. In grade 9, you learned that if you have a product to an exponent, you can distribute the exponent into the product. That's true. But if you have a sum or a difference, does that equal that? No, it most certainly does not. Because remember, foiling that out gives you that. Oh yeah, there's that 2xy in the middle. Remember that? That's the same thing. You might be going, yeah, but you didn't square here, you square rooted. But this is something we'll talk about in the next chapter. A square root of something is in fact an exponent. Some of you might know this already. It's the exponent of 1/2. Radicals are fractional exponents. Square root is a fractional exponent. So it follows all of the rules of exponents. And one of the rules of exponents is I can distribute an exponent into a multiply or a divide. In grade 9, you called it power of a product and power of a quotient rule. But there's no such rule that allows you to distribute a squared into an add or a subtract. It doesn't work that way. So when I decided, oh, I'll cancel these squares with this square root, you violated that rule. You distributed an exponent into an add, which you're not allowed to do. So that's a fun diversion, but that's kind of not the point of my lesson. So let's go back to my lesson.
Sorry.
That's okay. No, that's a great question. I'm glad to have answered it. Let's clear that up. You can't cancel that way. All right, so I guess I need coordinates here. So where does point V live? V lives at -4, 3. Where does W live? W lives at 4, 0. Determine the length of this line segment. Okay, so distance is, let's just write the formula down for the first time. x2 minus x1 squared plus y2 minus y1 squared. Okay, which one do you want to call 1 and which one do you want to call 2? It really doesn't matter. I usually go left to right. So I'll call this one x1 and y1. I'll call this one x2 and y2. Doesn't really matter which one's which at all. Okay? So the distance is the square root of, okay, so I'm going to take y2, which is 0, minus 3, and I'm squaring that, plus, okay, now the y's. Oh, wait a minute, I just did the y's first. Sorry. Duh. Actually, that wouldn't matter either. But I might as well follow my formula. Sorry, I'm not thinking. x2 is 4, and then, oh yeah, my favorite trick here. When I minus a negative, I go minus negative. Again, in my head, I'm literally taking the negative on that 4, rotating it 90 degrees, and sticking it into the subtract. That always works. And then y2 is 0, y1 is 3. There we go. Keep the order of the same as the formula. And that's going to be the square root of 4 plus 4 is 8 squared. And 0 minus 3 is -3 squared. And again, here we are going to have another arithmetic conversation. I would not be happy. Don't write this down. I'll write it in red because I honestly think this is a mistake. This would not make me happy. Do you get why that wouldn't make me happy? This answer here is, of course, is 64 plus 9. Is this thing 64 plus 9? No, it isn't. When you write negative 3 squared like that, that's negative 9. Again, it's a BEDMAS thing. BEDMAS says you subtract after you do exponents, right? So this is the negative of 3 times 3. Whereas when I put a bracket around it, now it's negative 3 times negative 3. And that's what I meant in the first place. So don't do that, okay? Okay, I don't want that cluttering up my notes because it's nasty, it's ugly, and we hate it, we hate it, we hate it. All right. Meanwhile, 64 plus 9 is 73. Is 73 a perfect square? No, so we're going to leave it alone. That's done. 73. That's the length. We could estimate it if you like. Let's see. 64 is 8. 81 is 9. Where are you between 64 and 81? You're a little bit closer to the 9, eh? A little bit closer to 81. So 8.6, 8.5, whatever. Good enough. If I want a decimal, I'll ask you for it.
If it is the case where we have to give you a decimal,
Then it'd be a calculator question, yeah. Yeah, it'd be a calculator question. All right, so there's my answer for example 2. Example 3. Why don't you try one? I'll pause the video so it's not sitting there looking at dead air. Somebody remind me after to start it again. Okay, started recording again, and now I'll try to catch up to you. So the distance is the big square root of, so x2 minus x1, so 1 minus negative 1, 1 minus negative 1, plus y2 minus y1, 4 minus negative 2. If you did yours in the opposite direction, you have negative 2 instead of 2 in that bracket, and you have negative 6 instead of 6 in that bracket, but you're going to get the same answer as me because when you square those things, you're still going to get the same numbers, 4 and 36. And last time I checked, 40 is not a perfect square. Now, again, you maybe haven't seen this yet, and we're going to do a whole unit on this where this is the first lesson coming up next. But you can simplify that to 2 root 10. And weirdly enough, to a mathematician, they think that's a simpler answer. Because we haven't actually done this unit yet, I'm happy with that answer. I'd mark it right if this was a test.
wait, how is it?
Do you see how it's 2 root 10?
No, I could understand 4 root 10 because like that.
Well, remember that when you put a number beside a bracket, you're timesing them, right?
So 2 times 10.
How about this? The square root, okay, when we do this as our lesson in chapter 4, act surprised. The square root of 40 is the square root of 4 times 10, right? And what did we say the square root really is? It really is an exponent. So I can distribute the exponent into a multiply. So I can think of this as the square root of 4 times the square root of 10. I have no idea what the square root of 10 is. 3 point something. 3 point something with no end to the decimal, right? It's irrational. But I know the square root of 4 is 2.
Okay.
So that's where they get it from. So all I ever do when I'm doing these final answers is I look at them and I go, are there any perfect square factors in my answer? And if the answer is yes, I factor them out of the bracket. And if the answer is no, I leave it alone.
So they're just trying to be difficult.
It's not a matter of being difficult. It's a matter of this to a mathematician is a simpler answer because the irrational part is as small as possible. Does that make sense? All right. Do we need the picture? Not really. The distance is, we'll make this x1 and y1. We'll make this x2 and y2. But again, keep in mind, that's a completely arbitrary choice on my part. So it'll be negative 6 minus 4, all squared, plus, oh wait, I did it again. I keep putting the y's first. I'm sorry. Again, not that it matters. You can remember, you can add 2 things in anywhere you want, but I'll try to keep the formula consistent here. So 3 minus negative 2. There we go. That's the x's first. And then negative 6 minus 4 squared. There we go. So the distance is 3 minus negative 2, negative 6 minus 4. So that is the square root of 5 squared add negative 10 squared. You know, on this step, if you didn't even write that negative anymore, you know it's about to go away anyway, right? You're about to square a negative, which ends up positive. And you're going to get 25 plus 100. And again, here in chapter X, chapter 7, whatever, I'm happy with that answer. But once I've taught you chapter 4, if this was an exam question because we'd have been finished chapter 4, that's going to cost you half a mark. What perfect square is in 125? 5's a perfect square? 25. So the 25 comes out of the radical and it becomes its square root. So it's 5 root 5. There we go. But again, for right now, that's a perfectly good answer. I'll take it. This is interesting. Here's a kind of a problem-solving situation. Determine whether the following triangle is isosceles. Who remembers what that means? Two sides are equal. Now, we do have the benefit of a diagram, right? Clearly, WU must be smaller, but it seems pretty reasonable to me that VW and UV could be the same length. So if the distance from W to V, and that's exactly what my writing's saying. I'm just kind of writing in symbols. My distance from W to V is equal to my distance from U to V, then triangle.
Delta.
What's triangle? UVW is isosceles. What do you think? All right, let's see. Well, I guess to be able to do this, we're going to need coordinates. What's W's address? W is negative 3 over and 4 up. What's U's address? 1 over and 3, 4, 5, 6 up. And V lives on the wrong side of the tracks at 2 and negative 1. It's an expression. It's a colloquialism. Okay, next, let's do the first one. Let's do distance from W to V. So, okay, so distance from W to V. So from W to V, negative 1 minus, or so, oh, let's do the x's first. That's the third time I've done that. 2 minus negative 3 squared plus negative 1 minus 4. Does everybody get how I got those numbers? I don't really want to label them as x2, y2 because when I do the next one, I might change my mind as to which one's which. So can you just see how I got that? This guy minus this guy, and this guy minus this guy. And if you're good at arithmetic and you want to just skip some steps here, that's fine. 5 squared is 25. 5 squared is 25. So we're looking at the square root of 50. And again, if you've kind of caught the hang of the whole simplification thing, that's 5 root 2, right? That's 50 is 25 times 2. But I'm happy with, again, I'm happy with that. So now, if DUV doesn't give me the exact same number, then this is not an isosceles triangle. So let's see. So from U to V now, negative 1, or sorry, 2 minus 1 plus negative 1 minus 6. Oh, I think you're wrong. 1 plus 7 squared is 49, isn't it? Yep. Therefore, it is isosceles. Scalese. Yay! And that's the distance formula. That's it. That's how you use your new formula, distance formula. We're going to do an even easier formula. I did the hard one first.
You're sure this is a pretty simple formula?
I'm telling you. This one's based on Pythagoras. The next one, how do you average two numbers?
Add them together, then divide.
You got it. You add them together and divide by 2.
Seriously?
Okay, so there's a homework page here that you can work on. Again, I'm giving you an entire work day tomorrow. We'll talk more about that in a minute. Okay, so the midpoint formula is, I'll put the midpoint between any 2 points, and again I'll say x1, y1, and x2, y2 is the average of the distance between the coordinates. So you can kind of see, this time they gave you the formula. Feel free to use a highlighter or something and highlight it. We don't have to write it out again if you don't want to. So literally, take the two x numbers, and like you just told me, how do you find the average of two numbers? Add them up and divide by 2. Told you it was an easier formula. So let's try using it. Let's find midpoint M of this line segment. Okay, well, the first thing I got to do is read the points that I have. C is 2, 1, and D is 4, 7. So my midpoint is, and here I'll write it out as a formula first, x1 plus x2 over 2, comma, y1 plus y2 over 2. Notice that maybe the one thing about this formula people get mixed up on is they think this is some sort of equation. It is not. It's a set of coordinates, right? Does that make sense to you?
That comma looks a bit more like just a dot up here, so I almost thought it was multiplying.
No, that's meant to be a comma.
Yeah,
They are. It is coordinates.
X and Y, right?
Oh, yeah, I see what you mean. Okay. All right, let's put in the numbers. So again, does it matter what order you add two things in? No. So again, it doesn't matter which one I call 1 or 2. I'll go left to right. So 2 plus 4 over 2 will give me my x coordinate. And my y coordinate will be 1 plus 7 over 2. So we're looking at 3, comma, 4. And let's just plug it on here and see what we think. Does this look like the middle? 3, 4? Looks pretty middle to me. All right, do you need a picture? No, not really. So why don't you try one?
This is to find the midpoint. This is not to find the distance.
Yeah, the midpoint, the point in the middle. And a point has two names, right? An x coordinate and a y coordinate. All right, you saw the way I did that one? You can try the next one. Now you don't need a picture, they just give it to you. So again, I'll copy out the formula here. And you plug in the numbers. Plug and chug mathematics. Plug numbers into a formula, chug out an answer. Yeah, sometimes the distance between 2 points is not going to be a whole number, as I think this example just proved to us, right? So let's see. Let me catch up to you now. When I go -3 plus -8, I might as well just write that as -3 minus 8 over 2. And the y coordinate is 5 plus 1 over 2. Well, the y coordinate's going to be a nice whole number. 6 divided by 2 is 3. But that x coordinates, how about we just leave it as a simplified fraction? -11 halves. Right? If you really wanted to, okay, the decimal on that would be -5.5. But it doesn't really matter to me which one. Doesn't really matter to me which one of those you pick. Okay? All right. One thing. Now, this is an easier formula, but it does lead us to maybe more complicated questions that I probably wouldn't ask you with the distance formula. Like, for example, what if you know the midpoint, but you're missing the end point? So example 3, I got point -2, 2. Let's graph it. -2, 2. There we go. There's point J. And I have point M, which is the midpoint, at 1, -1. So this is the midpoint of a line segment. I know that it goes from here to here. How much further does it go, and what's my other end point? How could we solve that? Well, here's the basic formula again. It's the average of the two sets of coordinates. But I can actually make two little equations out of this.
You know what one x is and you know
I know one of these x's, so I'll just say that I'll pick the second x. The second x is -2. The first x, I don't know what it is, so I'll just say that I'll just call this x1, I'll just call that any old x. X plus -2 divided by 2 has to equal 1. Do you get how I got that equation? Because I know this coordinate has to be 1. I know this coordinate has to be that number. So I can then say, all right, I'll times both sides of the equation by 2, and then I'll add 2 to both sides of the equation. There we go. It must be a 4. And then I can make a different equation. I'll use a different highlighter. I know that this value has to equal -1, and they tell me that one of those two numbers is a 2. So I'll call this one the 2, and I'll call that one just some y that I don't know what it is. So y plus 2 over 2 has to equal -1. Do you get how I made that little equation? Could I make an equation that has both x and y in it? No, because they're actually two completely different directions. You couldn't mix them together in an equation unless you tried to do Pythagoras or something. That'd be a little complicated for this. So times both sides of the equation by 2, minus 2 from both sides, and there's my midpoint, or sorry, my end point. End point is 4, -4. Let's see, does that look right? 4. Well, my line got a little crooked, but not bad.
It was pretty accurate.
Not too bad. And that was point, oh yeah, this is point K. All right, you've seen me do one. Why don't you try one? This time they don't give you the picture, so just do the algebra. Once again, I'll pause the video and give you a minute. So your turn. And pause. And we're back. All right, so I know that the point 3, 2 is the midpoint, and I know one of the x coordinates is -1, so why don't I say x for this x1 plus -1, and I'm never going to write x plus -1. I'm in grade 10 here, not grade 8, so x minus 1. And then for the other one, I know some y coordinate, which I'll call y, plus this 5 divided by 2 is my other coordinate. And then I make two equations out of it, right? I know this, again, hang on, let me use my highlighters. I know that this part of the equation here has to equal 3. This term has to equal 3. So I'll make that the equation x minus 1 over 2 has to equal 3. And I know that this term here, or expression maybe is a better word, has to equal 2. So my second equation is y plus 5 over 2 is equal to 2. And then I just solve them separately, and that gives me my x and y coordinates. X minus 1 is equal to 6, so x is 7. Y plus 5 is equal to 4, so y is equal to -1. And there's my answer. And Q, therefore, Q is 0.7, -1. And that's it. That is chapter X.